Right, so guys, so this day, on week number five, we are going to learn about modern foundation. So, in our previous lesson, we talked about the algorithms, classification algorithms, how them since they have different usage or uses, no? So you have already learned what to use, whether this example or this AI problem should be solved or not, something like that. So we have talked about the decision trees, the KNN. So in your project sooner in AI, you will be using some classification algorithms. And for us to know how effective or how do we know if our model is actually good, this is where this lesson comes in. So if we are to, example, we are to build a spam classifier, how do we know that this spam classifier will work in a real world setting? Something like that. So this day, we are going to talk about these three learning outcomes in this presentation. Mm. This interpretation would be talked about in our lab exercise. So by the end of this session, you are going to explain the importance of evaluating machine learning models, construct a confusion matrix from predicted and natural results, and compute evaluation metrics such as the accuracy, precision, recall, and F1 score. So why is evaluation of models essential? First one is, of course, you have to ensure generalization to unseen data. Next is to compare algorithms fairly to guide improvements in model performance. Ito algorithms, comparison of algorithms fairly because this there are algorithms that can be used in one application. So we can compare all of the algorithms and then look at which of these models have the highest accuracy and have the best application. So we can compare them and we can see which models is fit and which model is fit for the best among the models that we are going so that we can use the best model that we have currently have, right? So also to guide improvements in model performance and of course to avoid misleading results, especially in an imbalanced data set. Example kasi, we will talk about that later on. In 1,000 patients, say for example, cancer and not, mas madami talaga yung walang cancer kaysa sa may cancer, right? So this will have an imbalanced data set. And we're going to avoid some misleading results to that one. So our focus for today would be about the classification metrics. So I'm not sure, or I'm sure, I may be sure, maybe in your in your data science, you maybe have already talked about some clustering and regression metrics, right? So this in AI, we are going to know about some classification metrics since we are going to focus on the image processing techniques in AI. Now, I have here a confusion matrix table. So in our confusion matrix table, we are going to have action positive, action negative, predicted positive, and predicted negative. So this this table shows that this table shows the number of, for example, we are going to test our the accuracy of our model in a real world setting. And we are going to create a table right afterwards. So okay, let's talk about the confusion matrix. What actual positive is and what actual negative is. So actual positive is the ground truth positive cases. Patient really has a cancer. Actual negative is the ground truth negative patient. The patient is a healthy patient. So uh, a true positive naman is that it is predicted positive and actually positive. That is correct. A true negative is that here the patient is predicted negative and actually negative, right? So hindi siya, wala siyang cancer, that's too negative, right? Or in other words, the patient is healthy. False positive naman is predicted positive but actually it's negative. So it means to say that it is predicted that there is she or he has a cancer, but actually in reality, it's he or she is not. Okay. Next is predicted negative, but actually positive. That is the false negative. So it has is actually predicted uh, around healthy. Well, in reality, that cancer truly has a patient. So take note, or you have to really think about the model that you're going to use, especially in a healthcare setting, because in a healthcare setting, the accuracy should be about 99%. That's how critical healthcare setting is, or in their setting, no? So let's say for examples, we have a false positive of one and a false negative of one. We have false positive, which is he or he is healthy, but it is wrongly diagnosed as cancer. Then false negative is that he or she is healthy, but he truly has a cancer. So this is what happens after we have built our model. We test it, we validate it, so that we can actually deploy it in a real world setting. So there are three out of four cancer patients, right? And then five out of six healthy patients. So let's talk about the metrics from the confusion matrix that we have. So based on this table, guys, we have the accuracy, which is a true positive plus true negative, over the true positive plus true negative plus false positive plus false negative. So earlier, we have seen that the often the true positive and the true negative is like uh, detected correctly. That's 8 out of 10. So meaning to say that that's eight corrected prediction. That's a total accuracy, right? There are eight prediction and eight correct accurate predictions out of 10 data sets that we have. That means to say that we have 80% accurate. Our model is 80% accurate, right? So this actually means that out of course, 100% accuracy, 80% tama yung ating model, right? I believe it's not that high because the number of data sets that we have tested is quite few. So for you to have a more parang reliable no, na accuracy, you have to test more for you to know. So now, when the model says positive, how often is it correct? And this is called the precision. So TP over TP, or the true positive over true positive plus false positive. So earlier we have 3, 5, and then 1, 1. And then this is predicted positive, predicted negative, actual positive, actual negative, right? So earlier in the table, we have the true positive and false negative. And then we have false positive and then true negative. Am I right? Yes. So meaning to say that this we have already gathered the entire accuracy, and now we have to know the precision of our model. So to know the precision of the model, we are going to get this, the accuracy of the positive kanang agtay cancer nga gusto natin mabalaan kung unsa how our model performs sa cancerous patients. So that's 3 out of 4, right? So this is called the precision. Okay, tama na? And then um, next would be the recall or the sensitivity. Sometimes it's called sensitivity, but in other publication or in other terms, they are called sensitivity. Or yeah, let's call it recall. So of all actual positives, ilan yung na-catch natin? Of all actual positives, ilan yung na-catch natin? So this is very important when false negatives are very costly. Kasi nga, class, this patient has a cancer, but he or she was predicted that she is healthy. False negative siya. So 75% is our recall in this case. Next would be the specificity. Specificity in our table. Let's copy this once again. All right. Specificity. Yeah. So of all actual negatives, how many were correctly rejected? So we're going to talk about the true negative and the false positive. So in this case, we have the specificity as this one. Of all actual negatives, of all the healthy patients, ilan yung correctly rejected? So meaning to say that that is 5 out of 6. That means that 5 out of 6 patients were correctly classified as healthy, meaning to say that that is 83.3% specificity. Okay, so in this slide, we are going to differentiate. Ano ba yung difference ng precision and recall? Or not the difference, like a scenario or a case study. Suppose a cancer detection model outputs a probability that a patient has a cancer. So pag yung doctor, sasabihin niya na mas mataas yung threshold probability than the threshold, it will predict as positive, something like that. And pag less than na dun, predict negative. For example, there is this very strict doctor. He wants a higher threshold, and he or she wants a higher threshold. And what happens is that there will be a higher precision, however, a lower recall. What happens is that pag gusto niya na 90 greater than or equal to 90% yung diagnosis, it it I mean, i-diagnose niya na greater than or equal to 90% cancerous yung patient. However, yung mga may cancer na 70% likelihood, they will be told healthy. And they are missed cases. No? Pag naman kasi, ilo-lower ng doctor yung threshold, say, if test shows at least 30% chance, I call it cancer. However, yung problem naman dito is that, although no cancer patient is missed, but lots of healthy patients gets false alarm. So, in applications, ano ba yung point ko dito? There are applications that we use this precision. There are also applications that we use recall, and they are all very important. So, for example, in spam filtering, we use precision. In medical tests, we use recall because again, in recall, the false negatives are very costly. So, may mga cancer patients doon na kailangan talaga nating i-detect, right? Now, to harmonize or to balance everything, we use what we call the F1 score. This is the harmonic mean. So, it's the harmonic mean of both precision and recall. So, it is very useful when classes are imbalanced. So, when we talk about the word imbalance, what does imbalance mean? When one say, or when one class, for example, negative, is much more common than the other positive. So in our example, it's very good because we talk about cancer. And I mentioned earlier that in this setting, mas madami yung healthy patients kaysa sa mga tao may cancer. So, for example, we are to gather a data set and 990 patients doon ang positive and only 10 people have cancer. So, positives are only 1% of the data. Hence, we need to use F1 score. And depende yan siya sa pagsulat ninyo sa result. Because in reality, mas madami naman talagang healthy patients, right? Kaysa sa may cancer. Okay, so we have a breast cancer detection using random forest. So what this means is that there are actually studies that have already been done. So from a machine learning project, diagnosing breast cancer benign versus malignant. Benign means that it is not harmful. Malignant means that there is a harmful substance or something. No. So harmful and not harmful na lang. Right? So in our confusion matrix class, we have true positive of 39, true negative of 72, false positive of 1. Like, okay, I made a mistake here. And false negative of 2. Okay, so this is the actual table of our case study. All right, after we have developed the model, which is the random forest, we have to be able to know the accuracy based on the testings that we have or validation that we have. Kasi may validation tayong gagawin in a split na testing natin. Meron kasi tayong train, test, validate. Okay, or train test split na tinatawag. So yung train test split, that's 70%. For example, training, 30% is for testing. Or sometimes, merong ginagawang 70% training, 20% testing, 10% validate pa talaga. No, but this is more common, especially when we start learning muna the confusion matrix. 70%. What does it mean? For example, meron kang 1,000 data set, 70% doon, which is 700, will be used for training. Ano ba yung ibig sabihin nun? Yung 700 images, yung gagamitin to train the model. Yung 300 remaining is used for testing. So, what does it mean is that yung 300, itetest siya kung okay ba yung 700 na train natin. Something like that. So this is what happens here. There are 114 samples tested in a real-world setting, right? So this is the key metrics, right? The accuracy, that's 39, correct classification. Atoms N72 is also correct. That's a total of something over 114. Yeah. And it gives us a 97% accuracy. Precision naman is TP over, I may mention earlier, not TP over TP plus FP. This is the precision. Okay, that gives us the 97.5. The recall of 95.12 is quite high, right? Everything is quite high. The specificity is the true negative, that's 98.63, and the harmonic mean of 96.3. Actually, this is already a good model. If we talk about like image classification for fruits, dogs, cats, it's very crucial if we talk about cancer detection. So the doctors or the experts really has a say whether or not they will use the model, right? Or they can use the model, but verifications na lang yung sa experts natin, yung sa doctors natin. So AI is very helpful to all of the industries or sectors that we currently have right now. So in our table summary, this is what we do, right? In the interpretation part of the paper. The model demonstrates high overall performance with accuracy of 97%. Precision is slightly higher than recall, meaning few positives but slightly more false negatives. It's a critical trade-off in a cancer screening context. The specificity is very strong and the recall is very strong. It's 98.6, meaning that it rarely mislabels a healthy patient. So ito kasi yung specificity, right? Isa lang yung incorrectly detected niya, yung ano tawag ng specificity. Diba? Specificity. Ano yung spelling ko kanina? Specificity. Then yung recall natin would be, yun siya, 95.12. What does it mean is that there are 39 out of 41 no, na nakuha natin for the recall. Meaning to say may two misdiagnosis. Tama ba? Misdiagnosis. Okay, and To balance both precision and recall, we have 96.3%. So in summary of what we have learned today, let me give you a recap. After kasi nga, di ba, pag nag-create tayo ng AI model, before that, there's a brainstorming that will happen. Para may input, pa kayong gagawin. And then after that, the methodology. So in the methodology, or the process rather, the input. So of course, the input, ano ba yung mga magbe-brainstorm pa kayo dyan? The process, yung methodology. So what algorithms are you going to use? And the output, ano yung output after ng ating uh, uh, model na create? Something like this. So this process takes a lot of process, takes a lot of time to do. It takes a lot of learning to do. So I can give you a supplemental materials for you to learn more about the metrics. And I thank you for watching this lecture. I hope you have learned a lot. Thank you.